All right, see Lindelof videos, solving exponential functions. What we're practicing in this series, this is the last of the 3 videos I'm going to do on this. What we're practicing in this series is are there times where we don't have to use logarithmic function to solve an exponential function? And the answer is yes. And the question when is sometimes. So let's look at this for a second. So let's look at our first function and let our first function say this, that we have 3 to the negative 2x plus 1 power times 3 to the negative 2x minus 3 power is equal to 3 to the negative x power. Man, don't pass out yet, because everything is actually going to be okay. All we have to do is think of some stuff here. The very simplest thing we're going to think of is that if we had any number, 7, for example, raised to the x power, and we said that is the same as 7 to some other power, you choose the power. Put a number here. You chose 7 again. That was really weird. Isn't it true that if these two match, then x must equal 7? So that's the first premise that we're going to act on. And the second thing that we're going to do is use our rules of exponents. Here's some really good news for us. We have base 3 here, we have base 3 here, and we have base 3 here. So we don't need to work on the bases at all. We have that kind of sorted. But we have to keep in mind that we know this rule, and we know from Algebra 1 that x to the power of m times x to the power of n is x to the power of m plus n, right? Well, this says the base has to be the same as this one. Well, these bases are the same. So what we can do is, if the bases are the same, we can just write the base down and add the exponents. So that's what I'm going to do. So I'm suggesting to you that this 3 and this 3 is what I'm looking at. So I'm saying they're the same base, so I'm going to take 3. And then I'm going to add their exponential values. The first exponential value is this one, so I'm going to take negative 2x plus 1 plus, and I'm going to put this thing in parentheses because if it was subtraction it would be a little bit different, plus negative 2x minus 3. So here's my negative 2x plus 1 came from here, and that's there. And then I took this exponent and I put it here, and this plus sign right here is this plus sign right there. So if you're going, so hopefully you're with me. So that's all I'm going to do. If you realize that this positive sign is not going to affect anything, I can just take this positive sign out and this out. So it just gives me this. So I get 3. Well, I have negative 2x's here and negative 2x's more here for negative 4x's, don't I? And I have positive 1 here and negative 3 here for a total of negative 2. Can we agree on that? All right? Is equal to 3 to the negative x power. So remember we were talking about that thing. If you had 7 to the x power is equal to 7 to, then you chose 7, that all you'd really have to do was compare these two things right here, this one and this one, wouldn't you? Well, that's what we finally have. So that's what we're going to do. Because these bases match here and here, all we really have to do is this piece of algebra right in there. So to solve for that missing value of x, that's all I'm going to do. I'm going to look at that. I like that color. I'm going to take negative 4x minus 2. That came from right here, right? This equal sign right here is this one. I'm just pulling the math down so I can see it. Remember, this is negative x right here, so equal to negative x. So what I'm going to do now is I'm going to add positive 4x's to both sides. I don't care how you do it. You can just move it around. But I'm going to move mine this way, I guess. So we'll get negative 2 is equal to, if I added 4x's to this side and 4x's to this side, 4x's minus 1x is 3x's, isn't it? So 3x's, divide both sides by 3, and we get x is equal to negative 2/3. And I really like that answer. I think that's a quality answer. So hope you like that. Want to try one more? Let's try one more. We have a minute to try another one. So let's actually try one more, you guys. Let's find one. And that, I'm looking. Let's find one more. Here's one. Oh, right. Oh, let's try this one. Let's try this one. I like this one. This one is similar, but different. We have 2 to the power of x times 1 over 32. So you see where the problem is here. And this is the problem that your professor or your teacher is going to get you on, because you're going to say, oh, yeah, Charlie was saying we had to have like bases, and we don't. Well, here's a question. Right, this is what I'm going to do here. in my head, I'm looking at this, I'm like, I wonder if I can put all this crap in base 2. So 2 to the 0 is 1, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is, look at it, is 32. So check this out. 32 is, that says is, equal is 2 to the fifth. So I'm going to take that 32 out and replace it with this 32 because 2 to the fifth power is 32. Also, look at this for a second. This 32 here is the same as 2 to the fifth here. And I want to remind you of something. I want to remind you that if we had 2 to the negative fifth power, we would have to fix that, wouldn't we? You're not supposed to keep a negative exponent up. You're supposed to clean it up so you take its reciprocal. Remember, negative exponents create fractions, so it's the same as 1 over 2 to the fifth. So I'm going to use that rule backwards and say this is the same as 2 to the negative fifth. 2 to the negative fifth. Check this out for a second. This actually works pretty well, doesn't it? So this should be going okay. Now what we want to talk about is another rule that we know about exponents, which is that x to the power of m times x to the power of n is equal to x to the, right, m plus n power. I can hear you out there. So I'm going to do that. I checked to make sure the bases are the same. The bases on the left are the same, so I'm going to say 2x plus, however, the plus, I'm going to have to add it to the negative 5, so plus negative 5 is equal to 2 to the fifth, right? Am I doing okay so far? So keep going here. Positive negative is a negative, isn't it? Go back to that same example we had about 7 to the x is equal to 7 to the 7th power. And once we know the base is the same, we just have to do this little piece of work up here. So that's what we're going to do. We're going to take this piece of work right here, set these things equal to each other, pull our math down. Do that math. We're going to say x, whoops, sorry about that. Say x minus 5 is the same as 5. X must equal 10. I added 5 to both sides, right? So there it is. Look, you guys, this is really possible. You have to do a ton of these problems, and keep in mind what you want is like bases. They're really powerful for exponential equations. If you have any questions or comments, please let me know. And if you haven't already subscribed, please subscribe. Thanks.